Okay, so let's take a look at an example now, or several examples where we have unlike denominators, okay, and then we've got to build up the denominators to be common. All right, so let's start with an example like 1/6 plus 3/10. Okay, so again, I'll go back to a numerical example, show you kind of the process, because with rational expressions, they're just fractions, and so the general principles are the same. It's just sometimes the details are more complicated. Okay, so here I've got unlike denominators or uncommon denominators, and I need to find the LCD. Okay, well the LCD between 6 and 10 is going to be 30, so I need to get those to be 30. Now how do I find 30? Well, there's a lot of different ways to find an LCD. One of my favorite methods for finding an LCD when there's just numbers is to use what I call the ladder method. I take the two denominators, put them under a division, and then divide out anything they have in common. Well, 6 and 10 have a common 2, so I would divide that out. 6 divided by 2 is 3, 10 divided by 2 is 5. And so I do the two divisions, and then if there's any common factors still, I continue this division. Okay, here 3 and 5 do not have any common factors, but if they had another common factor of say 3, I would continue to divide and build this up until I ran out of common factors. At the very end, the LCD can be found by multiplying the top right number by the bottom left number. 5 times 6 is 30. Or the top left number by the bottom right number. 3 times 10 is also 30. Or an alternate method is to take all the numbers on the outside. The 2 times 3 times 5 will also give you 30. Okay, so lots of different ways it shows up here. So 30 is the LCD. And this method will work every time, but I think as we get into more complicated ones, this gets a little bit clunky. It's nice with numbers, it's pretty fast, especially with big numbers. But as we get into the rational expressions and we get polynomials, this will work, but when you get polynomials under here, it just looks kind of clunky and hard to follow. So I'll show you a little bit nicer trick. Instead, what I would probably suggest here is to take the 6 and break it into its factors, like 2 times 3, and take the 10, break it into its factors of 2 times 5, and then just make sure essentially that every factor is included. Okay, so I know I've got to have a 2, a 3, and a 5. Here I've got another 2, but I don't need to repeat those. The only time you really need to repeat them is if you have powers on those. And so if I had like an x and an x squared, I'd want to use the largest power, okay? Other than that, I just want to make sure everything gets included once. So here, I need a 2 times a 3 times a 5, which is equal to 30 as well, okay? So that's going to be the method we're typically going to be looking at here. So, got my 30. Now I need to figure out what I need to multiply each of these by to get 30. Well, to get from 6 to 30, I need to multiply by the 5, just like in this ladder here. So I'm going to multiply the bottom by 5 and the top by 5. And then the second fraction, I need to multiply by 3. So I'm going to multiply by 3 to the top and the bottom. When I do that, it doesn't change the value of either fraction, just what it looks like. Okay, so 1 over 6 becomes 5 over 30. And 3 over 10 becomes 9 over 30. Okay, 5 over 30 and 9 over 30. And then you can add those two numbers together. So 5 plus 9 is 14, just like we did with common denominators. And then, of course, if it reduces, we should reduce. So 14 over 30 reduces. If I divide both top and bottom by 2, we'll be left with a 7 over 15. Okay, so with numbers, it works out fairly well to get a common denominator, but the idea is you need to find the LCD, which we can break things apart, factor them, okay? And when we get into polynomials, we'll be factoring. And then just include every factor, okay? Or the largest power of each factor if you have powers on them. Then you multiply by whatever's missing, right? So the 6 has the 2 and the 3, it's missing the 5. The 10 has the 2 and the 5, it's missing the 3. All right, so you multiply by the missing factor essentially, and then build up your fractions, add together, and simplify at the end, okay? All right, so let's try this with a rational, with rational expressions. Maybe I'll leave this up here just so we can see kind of the layout. So with rational expressions, let's do something kind of basic. Let's do 5 over 2x minus 3 over, let's go 7x squared. Okay. So when I try to combine these, I have rational expressions because I've got I've got variables involved. And now I need to find the LCD first. Well, if you think about it, the LCD includes the factors from the first fraction, the factors from the second fraction that were not already included, and if it was included, make sure you get all the highest powers included. So I'm going to square the x. So I've got the 2, the 7, and I want an x squared rather than just an x. And then all these combine to give me 14x squared. Okay, 14x squared is going to be my LCD. That is the smallest expression that I can use as a multiple of both denominators. So to get 14x squared, well, the question is what's missing here from the 2x? Well, I have a 2 and an x. I need the 7 and the other x. So I'm going to multiply by 7x. And I'm going to do that to both the top and the bottom. This one, from 14x squared to 7x squared, I'm only missing a 2, right? I have both of the x's. So I'm going to multiply that one by a 2 on the bottom and 2 on the top. Now when I actually combine these, 7x times 5 is 35x. On the bottom we get 14x squared. And then we have our subtraction, and we get a 6 over, what's that, 14x squared again. Okay. Now we have our common denominator, so all we really have to do is combine the numerators, and we'll get 35x minus 6 all over 14x squared. Now here I do not have any way to factor. There's no common factor to pull out. There's no other way to factor these. Okay, and so we have our most simplified form, and that would be our final answer. Okay, so again, the idea is find the LCD, include every factor, and if there's repeated factors, make sure to include the highest power. Then multiply both fractions by whatever factors are missing. Then do the multiplications, and then add the numerators or subtract the numerators, whatever you need to do. Simplify if possible or if necessary at the end. Okay, let's look at a little bit harder example, or a couple more difficult ones. Grab a couple where we have to do a little more work. Something like 2 over x plus 3 plus 5 over x squared minus 9. Okay, so in this example, my denominators are not the same. And so I'm going to factor them, okay? I don't know, well, here I've got x plus 3. That one doesn't actually simplify or factor. X squared minus 9 does. It's a difference of squares. So I can use x plus 3 times x minus 3. Now I'm just going to write the factors underneath there and then kind of ignore what was originally there. Because they're equivalent, I can replace them. So if I think about what my LCD ought to be, the LCD has to include an x plus 3 and an x minus 3. I don't need any more x plus 3's because in both denominators, the x plus 3 has only a 1 power, so I don't have to worry about including a highest power there. The 1 power is the highest power. So my LCD in this case is simply x plus 3 times x minus 3. It's that product. Those are the only two factors involved. And so the second fraction already has the LCD. I don't have to worry about doing anything to it. The first fraction, however, does not. So I need to multiply that by the missing factor, which is x minus 3. And if I do that to the bottom, I must do that to the top as well. And so when I do that multiplication, we're going to distribute the 2. Right? So this distributes to both of those terms. We'll get 2x minus 6. On the bottom, I'm just going to write this in its factored form. There's really no need to distribute them together because we may end up having to factor apart and simplify at the end. So we'll just leave them separated. Here, we're going to add in the 5 and the, again, x plus 3 and x minus 3. Okay. So now that I have common denominators, we just add together the numerators. Of course, 2x doesn't combine with anything. Minus 6 plus 5 is a minus 1. So we really have 2x minus 1 all over x plus 3 times x minus 3. Okay. Here, the 2x minus 1 does not simplify, or doesn't factor, and it does not simplify or cancel with anything on the bottom. And so this is going to be our final solution. Okay. All right. Let's get into some even more difficult ones, where there are more factors in the denominators. How about something like x minus x squared over x squared plus 6x plus 5, and then we'll do minus let's do 3x minus 2 over let's do this one. Is that right? Minus 4x plus 3 minus 1. No. Let's do a plus. Let's do a minus 5 right there. That's better. Okay, let's try this one. Kind of making this one up as I go. So here, I've got two very unlike denominators. What I want to do again is factor them to find the LCD, try to figure out what factors I need in the LCD. So this first denominator I'm going to factor out. Both of these are nice because they each have a lead coefficient of 1, so they factor nicely. Factors of 5 that add up to 6 are 1 and 5. So we have x plus 1 and x plus 5. Factors of negative 5 that add up to negative 4 are 1 and negative 5. So I have x plus 1 and x minus 5. Okay, so those we can do pretty easily, hopefully, at this point. Now, as I look at these, I see some common factors, right? I have an x plus 1 and an x plus 1. So I only need one copy of that in the LCD. Let's write the LCD up over here. LCD is going to include an x plus 1. I also need an x plus 5 and an x minus 5. Okay, so I've got to have all three of those factors. All right, so in the first fraction, we already have two of them. We are missing the x minus 5. So I've got to multiply top and bottom by x minus 5. Okay. In the second fraction, we are missing the x plus 5. So I need to multiply the top and bottom by the x plus 5. Okay. So now remember, when I bring these down, my denominators I'm going to leave in their factored form, okay? And really they're each going to be this LCD. The numerators, however, I'm going to go ahead and distribute so that I can combine the terms when I subtract the two fractions together. So on top, I'm going to go ahead and distribute. That's going to be x squared minus x cubed minus 5x plus 5x squared. Okay, so that's my numerator. It's quite a bit bigger than we've been looking at now. My denominator, again, is just the three factors, x plus 1, x plus 5, and x minus 5. Again, the order doesn't matter because we're just multiplying those. Then I have my subtraction. Then I'm going to do some distributing here. Think about that as a single factor. I probably should have done that here as well. Our numerators are just a single factor we distribute through. So 3x times x is going to be 3x squared. 3x times 5 is 15x. Negative 2 times x is minus 2x. Negative 2 times 5 is negative 10. And again, we have the LCD on the bottom, x plus 1, x plus 5, x minus 5. All right, so now at this point, I can combine my like terms, but remember, we're subtracting, so that subtraction has to distribute through to every term on the right. I'm going to go ahead and rewrite this out just as one big fraction, where I write all the terms from the numerators together. So I get x squared minus x cubed minus 5x plus 5x squared minus 3x squared, then minus 15x, then a double negative makes a plus 2x, and then here a double negative makes a plus 10. So again, changing all the signs on the right. And dividing by the LCD, x plus 1, x plus 5, x minus 5, it's all under the same on the same denominator. And now I combine my like terms. I see there's an x cubed, so I'm going to go with that one. It's going to be a negative x cubed. I see an x squared, 5x squared, and a minus 3x squared. These two make 2x squared, that makes a 3. So 3x squared. I got minus 5x, minus 15x is minus 20, plus 2 is minus 18x. And then the constants, I just see this 10 on the end. And then on the bottom, I have my LCD. X plus 1, x plus 5, x minus 5. Okay, now as I look at this, I can already tell this is not going to factor the numerator anyway. I could pull out an x squared, but I'm going to have like an x plus 3 in here, or minus negative x plus 3. And here if I pull out a 2 is the only thing common, I'm not going to have the x plus 3. So I'm not going to have any, I'm not going to be able to go through a whole grouping process with those four terms, because the corresponding binomials will be different and there's not really going to be any way to rearrange those to make them factor out. So, so this is it. This is as far as we can go. It does combine two pretty big fractions into one, still pretty big fraction, but it's nicer to have one than two of them.